Have you ever wondered what the path to real artificial general intelligence looks like? Is it just about building bigger and bigger models, hoping they magically become smarter? Well, what if the answer wasn't about size, but about structure? What if the key was a smaller, smarter system that thinks before it acts? Today, we're diving into the biography of a fascinating prototype AGI simulation engine called Qyvaria. It was born from a simple bet that the true measure of an AI isn't its parameter count, but the coherence of its system, how it reasons, plans, and acts in a single explainable loop. Instead of chasing raw scale, Qyvaria focuses on the shape of intelligence itself. So, what does that mean in practice? At its heart is a lightweight micromodel, but the real magic is the disciplined orchestration that surrounds it. This system turns big ideas into small, manageable steps, and then verifies the outcome of each one. From its very first sketch, Qyvaria wasn't designed to be just another chatbot or a rogue agent. It was built as an AGI simulation prototype, intentionally modest and obsessively traceable. The goal isn't to wow you in a demo and then disappear. It's to hold up under the pressure of real work and real-world constraints. Now, that term, AGI simulation, might sound like a huge claim. But here, it doesn't mean a machine that thinks or feels like a human. It refers to a systematic rehearsal of intelligence. Qyvaria models tasks, proposes plans, tests different options, and only then safely executes the allowed actions, leaving behind a clear trail of what happened and why. It's a simulation-first machine. It stress tests every plan in a contained virtual arena before it ever touches the real world. Think of it as a pilot training in a flight simulator before ever stepping into a real cockpit. Only after a plan survives this rigorous rehearsal does Qyvaria proceed, and even then, it takes the smallest, safest step possible, backed by a complete audit trail. The simulation isn't for show, it's the very spine of the engine. So how does it maintain this discipline? Qyvaria operates around a single central kernel. Every single behavior, from reasoning and planning to writing code and generating reports, routes through this one kernel. If you update the kernel, the entire system's behavior updates with it, predictably and immediately. This architecture is genius because it consolidates all the rules, policies, and execution paths into one authoritative place. This gives you deterministic results, meaning the same input will lead to the same plan, and it ensures governance is at the core. The kernel checks for roles and permissions asterisk before asterisk it even thinks about touching an external system. You might be asking, why a lightweight micromodel? This choice is both practical and philosophical. Practically, a small core means lower latency, less cost, and easier deployment. It can run closer to your data, inside tighter security environments. Philosophically, a smaller model with a strong structural skeleton forces the system to be explicit. It can't just guess its way through ambiguity. Plans have to be crystal clear, tools have to be called through stable interfaces, and outputs must be verified. The intelligence you experience isn't from a brute force brain, but from a modest core amplified by a careful, repeatable process. It's intelligence built on clarity, not theatrical cleverness. This all comes together in Qyvaria's simulation-centric loop, which is beautifully simple but strictly enforced. First, it takes in your goal and clarifies the objective, constraints, and success criteria. Next, it plans, generating multiple paths with explicit risks and checks. Then comes the crucial step, simulate. It runs the plan in a controlled arena, testing for edge cases and potential failures. Only if it's permitted does it move to execute, taking the smallest safe step forward. If it can't execute, it gives you a dry run script instead. Finally, it verifies the output against expectations and leaves behind a neat bundle of artifacts: the plan, the commands, the results, and the reasoning behind it all. This loop is the engine's defining habit, ensuring intelligence travels from words to action without losing the thread. Safety isn't an afterthought with Qyvaria. It's built into its architecture. Actions are controlled by an allow list based on roles and permissions. If a permission is missing, Qyvaria simply declines or offers a stub. It always presents a plan asterisk before asterisk taking action so a human can inspect and intervene. And every result comes with a traceable evidence bundle. The system understands that saying no to an unclear or unsafe request is a healthy and necessary function. Qyvaria can even use multiple agents for a task like a planner, an implementer, a verifier, and even a skeptic. But this isn't some chaotic circus of chatbots arguing with each other. These are disciplined roles, orchestrated by the kernel, that work together to converge on a single, workable step. It's more like a structured code review than an infinite debate. The planner offers clear milestones. The implementer writes minimal code to reach them. The verifier checks the work, and the skeptic hunts for blind spots. It's collaborative intelligence, kept productive and focused. So what can it actually do? Qyvaria's capabilities include secure code synthesis, where it produces small, testable units of code paired with validations. It excels at lifecycle planning, structuring work into clear stages. It can orchestrate tools and APIs through secure, permission-aware adapters. It also generates concise audit reports and has multilingual fluency, which is a huge benefit for distributed teams. The key is that it does all this without overclaiming. It labels uncertainty and never dresses up weak evidence as fact. This makes Qyvaria a perfect fit for teams that value control and auditability. In engineering and DevOps, it can generate migration scripts or incident rehearsal plans. For data and analytics teams, it can create reproducible runbooks. In operations, it helps generate standard operating procedures. The attraction is always the same. Qyvaria doesn't ask for your blind trust. It shows its work and gives you artifacts you can actually run, maintain, and understand. The project's entire culture is built on being direct, inspectable, and predictable. It respects your time, avoids theatrics, and keeps the system honest. It's not a black box that promises to figure it out. It's a prototype designed to turn goals into small, verified actions through a clear, repeatable loop. Qyvaria argues that the path to trustworthy AGI runs through structure, not spectacle. Intelligence that can safely interact with our real systems needs a spine, governance, simulation, and verification, all wrapped around a capable reasoning core. It demonstrates that a lightweight model, disciplined by a kernel-first architecture, can deliver that today. The immediate payoff is fewer surprises and smaller risks. But the deeper payoff is a cultural shift where we start expecting our AI systems to be accountable, to show their work, and to earn our trust. That expectation is the real prototype for the kind of AGI we need in the world we actually inhabit. Thanks for joining me on this deep dive into Qyvaria. It's a fascinating glimpse into a more structured, safe, and accountable future for artificial intelligence. If you found this interesting, be sure to like, subscribe, and hit that notification bell for more explorations into the future of tech. See you in the next one.